this video I'm going to be talking about functions, compositions of functions, inverse functions, stuff like that. We're going to be looking at functions given with an equation algebraically. We're going to be looking at them graphically, where you've got a picture of the graph, and we're going to look at them numerically, where you've got a table of values given to you. All right, so the first example I've got is just two functions. F of x is x squared plus 2x minus 5, and g of x is 4 divided by x, and then subtract 2x. Okay, well, I think something that we mostly all know how to do here is how to find, say, like f of 1. Okay. Well, we're going to plug in 1 for x, so that's 1 squared plus 2 times 1 minus 5 is 1 plus 2 minus 5 is negative 2. Now, something like g of negative 2 is going to be 4 divided by negative 2 minus 2 times negative 2. So this is negative 2 plus 4 is positive 2. But I know y'all already know how to do that. What we're going to talk more about today is like composition of two functions. What's f of g of x? What's g of f of x? What's f of g of 1? What's g of 1? Something like that. Okay, so, all right, so it's saying find f of g of x. Well, f of x is equal to x squared plus 2x minus 5. Okay, so what I'm going to do is wherever I'm seeing x, I'm going to replace that with g of x. So that's basically what I've done here is I've plugged in g of x. Okay, so f of g of x is g of x squared plus 2 times g of x minus 5. And then I have a formula for g of x. That's 4 over x minus 2x. Okay, so that's 4 over x minus 2x squared plus 2 times 4 over x minus 2x, and then subtract 5. Okay, and you could go ahead and like square that binomial maybe, or double that thing when that time comes. Or you could not, and this would be just as correct. Okay, so this is I would tell you to stop. Right, this is a safe place to stop. Okay, on the other side, we've got g of f of x. Okay, so I might just say find g of f of x. Okay, now remember, g of x is 4 divided by x minus 2 times x. So g of f of x, I'm just going to have to plug in f of x wherever I saw x initially. So it's going to be 4 over f of x minus 2f of x. But I have an equation for f of x. F of x is x squared plus 2x minus 5. I'm going to actually drop this down so I have a little more room. And it's going to be 4 over x squared plus 2x minus 5 minus 2 times x squared plus 2x minus 5. And that's, good enough. Okay, well, what if they asked us about, something like f of x? Well, what I'm going to do is wherever I see x, I'm going to replace that with f of x. So f of x is going to be f of x squared plus 2f of x minus 5. Right? Well, if I want, then I substitute on f of x. That's x squared plus 2x minus 5 squared plus 2f of x, and then subtract 5. Okay? Again, you don't need to, bring out the box method over here and expand that trinomial or distribute it in the 2. You don't need to do that. Okay? All right, and if we wanted to do g of x, well, wherever I see x in green, I'm going to replace that with g of x. Okay, so that's going to be equal to 4 over g of x minus 2 g of x. And we can do that. 4 divided by 4 over x minus 2x minus 2 times 4 over x minus 2x. Just like that. Don't try to do any additional algebra steps. Just write down a formula that's valid. Okay? All right. So the next type of problem that we're going to see is this numeric problem. It's one where they give you a table of data, and they're going to ask you questions about the functions f and g. And what you're going to have basically is something like, values of the functions f and g are given in the table below for selected values of x. Answer these questions or find these values. Okay. So the first kind of level of difficulty that we're going to see is just the direct lookup. Okay, so I'm going to say f of 1 equals what? G of 2 equals what? F of 4 equals something, and G of 5 equals what? Okay. Well, I'll do f of 1 for you. You go over here, you find 1 in the x direction, then you go down and you see what f is at x equals 1. So f of 1 equals 5. Okay. You try the other 3 and see if you're able to do those. Question. All right, there you go. Okay, so G of 2 is 3, F of 4 was 3, and G of 5 is 4. This is a pretty direct lookup, not that difficult. Okay, but I will tell you, that is the type of question that will be on the quiz, will be on the test, right? Those are the ones that are supposed to be the easier items, where you just look it up in the table. Kind of like in the science section of the ACT, I think. Okay. So the next set we've got is some composition of function questions. So maybe f of g of 1 and g of f of 2. Okay. Well, my advice for this type of problem, for the composition of functions problems, is to start with the inside. Okay? So you're going to say, well, if I'm trying to take f of g of 1, I need to know what g of 1 is first. Okay? That's going to be the first step. Okay, so I will start off looking at g of 1, and g of 1 is equal to 2. So this is f of 2, because g of 1 equals 2. Okay, f of 2 is 3. You go into the, oh no, it's not. F of 2 is 4. Okay, so you can conclude that f of g of 1 is equal to 4. Okay. You try g of f of 2, see how that one goes for you. All right, there you go. So you start with f of 2. Okay, you go to the table. F of 2 is 4. You plug 4 into g. G of 4 is going to be 1. Okay, so you just plug it in twice. Okay, just kind of follow it around. Okay, that is the composition of functions question using the table. It's nothing too crazy. Okay, kind of now the repeated iteration of the same function composed with itself. Okay, so f of 4, okay, we're going to start with the inside. Okay, f of 4 is equal to 3. So, taking f of 3 because f of 4 equals 3. Starting with the inside and then working our way out. And f of 3 is equal to 2. So f of 4 is 2. Okay. Y'all try g of 5. All right, there you go. And so g of 5 was 4. You plugged 4 into g again, and you got 1. Okay, so g of 5 was equal to 1. Now the next ones are kind of more extreme examples, but we can do these too. All right, so they ask us for f of g of f of 2. Okay, so what I'm going to start with is f of 2. F of 2 is equal to 4. So I've got f of g of 4. Okay, now I need to look at g of 4. G of 4 is going to be 1. So now I have f of 1. And that's going to be f of 1 is 5. Okay, so f of g of f of 2 is equal to 5. You try g of f of 3 on your own. See how it's going. Starting with the inside and then working your way out. Okay, there you go. So it ended up being 1. It was very similar to the last one. You just started with the inside, found that f of 3 was equal to 2, then found that f of 2 was equal to 4, and then evaluated g of 4 using the table all the way, and then you got 1. G of 4 was 1, yeah. All right, so now let's look at the graph examples. All right, the next set of questions we've got are related to a set of graphs. It's going to say something like, the graphs of f of x and g of x are plotted below for x between -10 and 10. Answer the following questions, or something to that effect. And so, the first kind of question they're going to ask, very easy, what's f of 1, what's f of 5? What's g of -3? And what's g of -9? Okay, and that's basically asking for f of 1. What is the height of the blue graph, that's f of x, at the point where x equals 1? Well, that's, right here, that's y equals 3. So f of 1 is equal to 3. Now, g of -3 is going to be, okay, you go over here to x equals -3, and you go up to the height of the red graph. That's 6. Okay. It's something that we can do. F of 5 is looking like 2, and g of -9 is, what is that? That's 4. So you're going to do these problems very similar to how you did the table questions. You're just going to, instead of pulling the data from the table, you're just going to have to interpret the graph. So we can get y'all a couple of composition of function questions. All right, we'll start with f of g of 2. Now, kind of the first order of business is to figure out, well, what is g of 2? Okay, well, g of 2 is going to be the height of the red graph at the point where x equals 2. That's 7. Okay, so this is going to be f of 7. And f of 7 looks like it's going to be 1. Okay. G of f of 2. Okay, again, I'm going to go through here. I'm going to figure out what f of 2 is. F of 2 is looking like 3 right there. So I'm going to plug 3 into g of x. And I'm going to get, okay, g of 3 is looking like 6 right there. Clear out all these markings I've made on the graph. And then I'll give y'all, 4 more to do on your own and see how you're doing with it. All right, and here we've got some repeated self-compositions. Okay, so f of 4, g of -3, f of -5, and g of -8. Okay, so y'all try these on your own. I think that y'all will be fine. All right, there you go. And I ended up getting 3 for all of these. Okay, I'm not sure if that was intentional or just some kind of accident, but you can see these functions spend a lot of time at y equals 3, so it's not surprising. You know, right? Just starting one layer at a time, starting from the inside and then moving out. So for like f of negative 5, you start with f of negative 5 and you find that that's 5. And you plug that into f of x and you find that's 2, and you plug 2 into f of x and that's 3. This is how we do those. Right. And now we're going to talk about some inverses and stuff. And inverses, that's just, you know, things that undo each other, like e to the x and natural log x we saw in the last unit. Those things undo each other. Okay, square root and square, those are inverses of each other. Adding 1 to a number and subtracting 1 from a number, also inverses of each other. All right, so I'm going to just go back and you think about, we know that y is equal to f of x on some sort of graph. Well, what I would say that means is that x is f inverse of y. Okay, so when we evaluate an inverse function, what we're doing is we're taking some output value and tracking it back to whatever input got us there. Okay? So another way that you can write these functions is we can say f is a function that takes in x's and gives you y's. Therefore, f inverse is a function that takes in y's and gives you x's. One definite key characteristic of an inverse function is that f inverse of f of x is equal to x. And f of f inverse of y would be y. Okay, so they just undo each other. And nothing has really happened when you do something and then you do its inverse. Hopefully. And I'm trying to think, oh yeah, another relevant fact about inverses is that if the point AB is on the graph of f of x, then the point BA will be on the graph of f inverse. If you're plotting them on the same xy plane, like scale. All right, we'll start by solving for inverses. And you know, this, I might go about this slightly different from how you did in Algebra 2 or Pre-Cal or somewhere else along the way, but it really is all the same. Okay, and what the instructions will be, the directions are for something like this, is something like find f inverse. That's pretty much what it'll say, right? And how we're going to do this is we are going to solve for x. Okay, that's really big, I think, because then it gives us a way to find the x if we know the y. That's what the inverse does, is it traces back to x from a given y value. All right, so for example, you know, something like f of x equals 2x minus 3. Okay, well, that's y equals 2x minus 3. And I'm just going to solve for x. Okay, I'm going to start by adding 3. And then I'm going to divide by 2. So x equals y plus 3 divided by 2. Okay. To me, this is a valid inverse. Okay. If you wanted to write it as f inverse, you could write f inverse of y equals y plus 3 divided by 2. And suppose you were working on like a multiple choice test or something and all of the f inverses were f inverse of x. Well, all you would have to do is like we were substituting earlier for our variable, saying f of g of x. Well, instead of f inverse of y, I'll just say f inverse of x equals x plus 3 divided by 2. But honestly, if you give me any of these three things along the bottom, I'm going to be perfectly happy. All right, the next one I want to do is f of x equals 2x to the third plus 5. This is y equals 2x to the third plus 5, and I'm going to solve for x. I'm going to start by subtracting 5. And then I'm going to I'm going to divide by 2 to get x closer to by itself. That's a minus in that. Now I can solve for x by taking the cube root of both sides. When I take the cube root of both sides of an equation, I don't have to worry about the plus or minus because there's only one cube root of a given number. Or the cube root of x to the third is always just x because they're, perfect inverses of each other. As opposed to x squared and square root of x, which, if you take the square root of x squared, that's actually absolute value of x. That's where the plus or minus comes from. Okay, so, you could write this as f inverse of y equaling the third root of y minus 5 divided by 2. Right, as f inverse of x equals the third root of x minus 5 divided by 2. However you like. Okay, here is one where we will have to concern ourselves with, the plus minus. Right? Okay, we're going to say that this is y is 3x squared minus 1. So I'm going to try to get at x by isolating it. So y plus 1 is 3x squared. Meaning y plus 1 divided by 3 is x squared. And then I'm going to take the square root of both sides of the equation. And that's where I have to remember the plus minus. Okay, and this is the inverse of f, but it's got a plus minus, so it's got two outputs for a given input, or it might have no outputs if y was, say, really negative. But that means that the inverse is not necessarily going to be a function in the vertical line sense, in the vertical line test sense of the word. We'll talk more about what a function is and isn't, I think, in the next lesson. But for now, I'm just going to remind you of something that you're already aware of. And so you could write this as f inverse of y is plus or minus the square root of y plus 1 over 3. That should be 1. Or f inverse of x is plus or minus square root of x plus 1 over 3. Something like that. Now the last one I'm going to have y'all solve for is f of x is equal to the square root of x and then add 2. Okay, so I'm going to write that as y equals square root of x and then add 2. And I'm going to try to get at x by subtracting 2 from both sides. And then I'm going to square both sides. So I'll have x equals y minus 2 squared. But y'all have been in this class long enough. Y'all know that I have to set up for FOIL on this. And this will be x is equal to y squared minus 2y minus 2 more y plus 4. Right, and you could write this as, if you wanted, as f inverse of x equals x squared minus 4x plus 4. I think that's enough as far as solving for inverses. Now we need to be able to evaluate inverses. Now when it comes to evaluating inverses, I'm going to give you the same advice, which is to solve for x. Okay. Now we probably need to, define what, if like k is some sort of y value that a graph hits or that a function hits, f inverse of k is equal to the set of all x's for which f of x is equal to k. So that's something we're going to use. But we're going to be solving for x. So I'm going to start with this table, the same table that we were working with earlier. And I'm going to actually extend this and add one more column, and I'll say like 6, 2, 3, or something like that. And the first thing we're going to ask is find me g inverse of 0. And remember, my advice is to solve for x. What I say on this is you say g of x equals 0, and then you solve for x. Okay, well, g of x is equal to 0. I am looking at the wrong example. I want g inverse of 5. Okay, that's embarrassing. All right, g of x is equal to 5. Yeah, all right, so you go on the row for g of x, and it's like, oh, here it is. That's g of x equals 5. You trace back to the x that got you there. That's x equals 3. So that means that g inverse of 5 is equal to 3. Maybe I ask you something like, find me f inverse of 4. And that's where I'm going to set f of x equals 4 and solve. So maybe I'll just let y'all think about that for a second. Get a hypothesis in your head. Okay, you go to the row for f of x, you find 4, and you trace it back to x equals 2. And you can conclude that f inverse of 4 is equal to 2. All right, and the last example I've got for you on this particular table is going to be f inverse of 2. And now I'll tell you, this is probably not something that you're going to see again in this course. We're not going to be dealing with inverses that are going to pull back more than one thing. But notice how we've got 2 twice over here. And the definition of f inverse of a number is going to be just the set of all x's for which f of x equals 2. So I'm going to set f of x equal to 2, and I will say x equals 3 and x equals 6. So f inverse of 2 would be the set holding 3 and 6. But you don't really have to worry about that for this course. That's not something that's going to come up very often, if at all. All right, well, what if they gave us a graph? And I'll tell you, this graph I'm going to make is a little different from the graph that you're going to see in your notes packet, but I think y'all will be all right. Maybe it does something. I'm going to just kind of graph g of x in, say, orange. And maybe, g of x is the type of function that's a little weird. It kind of comes down, it goes. Maybe it stops here, and then it picks back up somewhere else. We'll talk about this a little more next time, how that happens. This is the graph of g of x. And, I might ask you a question like, well, what is g inverse of -3? Well, g inverse of -3 is the solutions to the equation g of x equals -3. Right, so you go down here to x equals -3, and you kind of scan out to the left and to the right until you find the graph. Okay, I found it. And then you trace back to the x that got us there, and that's going to be x equals 2. So that's how we evaluate an inverse for, say for the graph. Okay, maybe I could also ask, what is g inverse of 5? Maybe see if y'all can do that. I'll freeze the screen. If you're watching at home, you just follow along. g inverse of negative 3 was equal to positive 2. All right, there you go. I go up to y equals 5. I kind of scan across until I find the graph, and then I report back that that happened at x equals negative 4. Now, something like, no, maybe g inverse of, what's that, 3. Okay, that one would be a little trickier. This one would pull back more than 1. Okay, because here is 3. You're going to hit there, there, and here. So we'd report back 3 values, but I'm not even going to include that in this video. It's just not something we need to worry about in this college algebra course. All right, the last example I've got for you is one where we're going to mix all 3 of these things together. We're going to mix the algebraic, the numeric, and the graphical. Okay, and what we're going to do is we're going to, just kind of compose these functions. And maybe I'll even write e of x. This will work. Where g is the graph, t is the table, and e is the equation. Okay. So maybe I'll ask you something like, what is g of 0? Okay. What is the value of the graph at x equals 0? Is it 0? Is it 4? Is it both? Is it neither? What are we thinking? Not sure. Okay. It's not negative 4. So what is the height of the graph in red when x is 0? So you go up here, and here we have an open circle kind of at the origin, whereas we have a filled-in circle over here. And that's what we do when we plot points and connect the dots. We're plotting points that satisfy the equation. We're not plotting circles that satisfy the equation. So this right here is a point on the graph. Oh, whoops, lost part of my axis. And this is something that you might talk a little more about in calculus or something. But what that means is that, we're getting really close to the origin from the left, but we're not actually getting it. You can get as close as you like, but we're not actually. Okay, so g of 0 in this case is going to be equal to 4. Well, what about t of g of 0? So what we just said, g of 0 was 4, so this will be t of 4. Wait. Yeah, well, we'd have to just make something up. And like I did, and that would be equal to 1. What about something like e of t of 3? Well, we're going to have to evaluate t of 3 first. Okay, we go here, we find x equals 3 on t, we find the y value. Okay, so that's going to be e of 0. And then we plug in 0. And that's going to be 0 minus 5 is negative 5. And really the last thing I've got for y'all is, well, how would you find something like e inverse of 9? Well, you would attack this one the same as all the rest of them. You're going to solve for x, and you're going to set e of x equal to 9. So you've got e of x equal to 9. And you've got an equation for e of x, that's x minus 5. And then I'm going to add 5 to both sides, and I'm going to say x equals 14, and conclude that e inverse of 9 is equal to 14. And that's all I got for you for this video.